Solving matrices or systems of equations with Gaussian elimination. Consider the system of equations x plus y plus z equals 5, x plus 2y minus z equals negative 3, and 2x plus y plus 3z equals 15. And we want to find x, y, and z. The first thing I'm going to do is I'm going to rewrite my system as an augmented matrix. So I have the augmented matrix 1, 1, 1, 5, then 1, 2, negative 1, negative 3, and then 2, 1, 3, 15. And I'll add the dashed line for my equal sign. It's not necessary, but I like to have it there. Now, we have one of two goals. Either reduce this matrix down to the following form, and if I do this, I know that what x equals, what y equals, what z equals. In practice, when I'm doing this by hand and not using a matrix calculator, I rarely go all the way down. It's just extra work of what I'm about to show you. But if I just need an answer and I'm required to do it by hand, I usually get it down to the following form. That is, I don't change my first row. And then my second row, I need a 0, and then I'll have other numbers, A, B, and C, whatever they are. And my third row, I want the first two elements to be 0, and the last two will be some numbers, D and E. So I'm going to try to reduce my matrix down to this, and then I'll solve backwards, and we'll see how this works. Now, what I'm about to show you is not necessarily the best way or the quickest way, certainly not the only way, but if you are required to solve matrices by hand, this way works. So I'm going to show you what I do. Now recall, or keep looking up here, referring back to this, I want to get my original matrix to somehow look like the one on the right. And I'm going to start by getting these first two elements to be 0. That is, I want a 1 up top and then zeros in the rows below in the first column. I'm going to do in the following fashion. I'm just going to rewrite my row 1, so 1, 1, 1, 5. Now, we are allowed to do 3 things, and 3 things in combination. I can switch the order of the rows if I want to. I don't want to here. I can multiply a row by a constant, and I can add 2 rows together and place it in a different row. Or like add row 1 and 2 and place it into row 2. So I'm going to do something like this. I'm going to do row 1 minus row 2, and that's going to become my new row 2. So let me actually align it here for us. I'm going to do row 1 minus row 2, and that will become my new row 2. Now, why did I choose to do this? Well, if I do row 1 minus row 2, and I'm going to do each element individually, so the first one up here minus the first one in the second row, so 1 minus 1 becomes 0. Well, that's what I wanted, right? I need a 0 over here. So the rest will be whatever it is, but I needed that 0 right there. So now I'm going to do the 1 minus the 2, give me negative 1. Then I'll look at my third column. The 1 minus a negative 1 gives me the 2. And then 5 minus a negative 3 gives me 8. Now, if you're not sure why I'm doing this, wait till I get near the end, and we'll see why this makes sense to do it. Okay. I want a 0 in my third row and first column also, and I'm going to use a combination of row 1 and row 3. So I'm going to do 2 times row 1 minus row 3 becomes my new row 3. So this is what I do pretty much all the time because I know it'll work. I'm going to do row 1 with row 2 becoming my new row 2. Row 1 with row 3 becoming my new row 3. And hopefully I'll get a 0 in row 2, row 3, column 1. Let's see if it works. If I do 2 times row 1 minus row 3, I get 2 times 1 minus 2 gives me 0. Perfect. That's exactly what I wanted. Now all the other numbers will be whatever they are. So I'm going to do 2 times this 1 minus the row 3. So 2 minus 1 gives me 1. And then 2 times the 1 minus 3 gives me negative 1. And finally, 2 times 5 minus 15 gives me negative 5. So I have what I want, at least to start. And after I do this, I'm going to do something one more time so that I get a 0 right here in row 3, column 2. And to do this, I'm going to rewrite column 1 and my new column 2 again. I'm just going to leave them as is. So first matrix, row 1 and row 2 to get row 2, a new row 2. Then row 1 and row 3 to get a new row 3. And now this last one, I'm going to do row 2 and row 3 to get a new row 3. And the reason I'm going to use row 2 and row 3 is because I have zeros right there. If you think about it, I've eliminated the x in row 2 and row 3. And I only have the y's and the z's. So how am I going to do this? Well, I have to look. You have to do a little bit of reasoning. But it looks like if I do row 2 plus row 3 and make that my new row 3, I will get what I want up here. So let's see if this works. If I do row 2 plus row 3, 0 plus 0 gives me 0. The negative 1 plus 1 gives me 0. 2 plus negative 1 gives me 1. And then 8 plus negative 5 gives me 3. Do you see why this works or how this helps me? Well, I can take this matrix, this new augmented matrix, and go backwards, can't I? If I look at my row 3 here, this simply tells me that z equals 3. Now if I look at row 2, that is my new row 2 up here, this says that negative y plus 2z equals 8. But I know what z equals, so I have negative y plus 2 times 3 equals 8, or y equals negative 2. And now I can go back to my first row, which says x plus y plus z equals 5. But I know what y is. So I have x plus negative 2, and I know what z is, so plus 3 equals 5. And then if I solve this, I get x plus 1 equals 5, or x equals 4. And I have the solution for negative 2, 3. And if you have a little time, go back and plug these answers 4, negative 2, 3 into each of these equations, and you'll see that you get a true statement. Let's do one more example here. What if we have the equation, or the system of equations, x plus 2y minus 4z equals negative 3, and then 3x plus 7y minus 15z equals negative 12. And finally, negative 4x minus 6y plus 15z equals 16. And I want to find what x, y, and z equal. I will start by making an augmented matrix. So I will get 1, 2, negative 4, negative 3 in my first row. And then 3, 7, negative 15, negative 12 in the second row. And negative 4, negative 6, 15, 16 in my third row. And recall that I want to get it down to a form like this. So I will leave my first column alone. I want a 0 in row 2, column 1, and then some numbers here, A, B, C. And then I want the first two elements in the third row to be 0, and then I'll get some other numbers, D and E. So let's do the same process that I did before. I'm going to keep my row 1 as is the entire time. I want a 0 right here, so I'm going to use a combination of row 2 and row 1 to get a new row 2. So what if I do 3 times row 1 minus row 2 and make that my new row 2? If I do that, I get 3 times 1 minus 3 is 0, exactly what I wanted. Now the rest of the numbers will be what they are. So I'll do 3 times 2 minus 7 gives me negative 1. Then 3 times negative 4 minus a negative 15 gives me a positive 3. And finally, 3 times negative 3 minus a negative 12 gives me positive 3 as well. Be very careful when you're doing these things. It is easy to make mistakes. And if you make any mistake up front, it's going to mess with you in the back end. So just watch all your numbers carefully. Now I want to get row 3, column 1 to be a 0. And I'm going to use a combination of row 1 and row 3 to get a new row 3. It looks like if I do 4 times row 1 plus row 3, making that my new row 3, I will get a 0 where I want it. So let's see if I do. 4 times 1 plus negative 4 gives me 0. Perfect. Now let's do 4 times 2 plus negative 6 gives me a 2. 4 times negative 4 plus 15 gives me a negative 1. And then 4 times negative 3 plus 16 gives me a positive 4. So I have my first two zeros. I now want to get a 0 in row 3, column 2, using row 2 and row 3. So I'm going to rewrite both row 1 and row 2. That is my old row 1, is still my new row 1, and my new row 2. And use a combination somehow of row 2 and row 3 to get a 0 here where the 2 was. So let's see. What if I do 2 times row 2 plus row 3 gives me the new row 3. Well, 2 times 0 plus 0 is still 0. That's good. That's why I use row 2 and row 3. How about the next one? Negative 2 times 1 plus 2, right? 2 times row 2 plus row 3 gives me 0. Perfect. Keep going. 2 times the 3 plus negative 1 gives me 5. 2 times that 3 plus 4 gives me 10. So what does this new final row say? Well, it says 5z equals 10, or z equals 2. And once I know z, I can go backwards up my rows and get the other values. So row 2, which says negative y plus 3z equals 3, could be written as negative y plus 3 times z, or 3 times 2, equals 3. So I get negative y equals negative 3, or y equals positive 3. And I can go back up one more time where it says x plus 2y minus 4z equals negative 3. Right, if I read my first row, I can substitute in y and z. So I get x plus 2 times y, or 2 times 3, minus 4 times z, or 4 times 2, equals negative 3. So I have x minus 2 equals negative 3, or x equals negative 1, which means the solution to my system of equations is negative 1, 3, and 2.